In this video, what I'll be doing is going over a few things in relation to pop-up pools for use with school swimming lessons, which is something that has been happening. Schools have been using these pop-up pools quite a bit over the last few years, and there's some concerns around the safety aspects of it. So what I wanted to address is not everything that you need to know, but just a couple of parameters that I'm going to work out for you. If you're operating one of these pools, or if you've got one of these pools on your site and you're using them for swimming lessons, you'll find this really useful. There's going to be quite a lot of working out to do, but I'll do it all for you on the screen and I'll explain it as I'm going. And the purpose is for you to compare the parameters that we're going to go through with industry guidelines, i.e. PUTAG, Pool Water Treatment Advisory Group, Code of Practice. The idea is to help you make an informed decision about whether or not your pool is meeting these parameters. Because if they're not, that's a problem, and you could end up in a lot of trouble if there's an incident that happens on your site, if there's an outbreak of some disease and it's traced back to the pool on your site and it's found out that you haven't operated the pool in line with the PUTAG Code of Practice, there could be potentially quite severe consequences. So anyway, let's get started. So the types of, I've been doing some research in preparation for this video, and what you'll see on the screen now is a typical pool size that is used. I've lifted this from one of the main providers. I'm assuming they're all using a similar sort of, and by the way, I'm not casting aspersions on any of the providers. I'm just going to present the facts as they are and go through the facts as they're presented. So the pool, we're dealing with 32 by 16 feet, 55 cubic meters or 55,000 litres. So that's what we're going to be working with, a pool that's 55,000 litres. And again, I'm making some assumptions here that all pools that are doing this pop-up school pools for schools type thing are using similar type pools. What I've done is try to find out some information around what type of filtration system and pumping system is being used. The manufacturers, Intex, again, I'm not casting aspersions on them either. They're producing pools, I would imagine, for domestic use, for someone to use at home. So, I don't think they ever intended these to be used on a commercial basis. But these are the types of systems, 925 gallons per hour, 2,200 gallons per hour. I'm assuming most pools are using this one, which is capable of dealing with 15,000 gallons. That's the biggest system that they've got by the looks of things. And we'll use this as the basis for working out a few key parameters. These parameters that we're going to go through, if you're running a pool or you're running a site that's got one of these pools, you need to be operating under a normal operating procedure, emergency action plans, pool safety operating procedures, and pool technical operating procedures. All this sort of stuff that I'm going to go through needs to be in there, all these parameters. So these pools, these systems designed to measure, go up to deal with a pool between 4,800 to 15,000 gallons capacity. Let's just do a quick conversion. Alexa, what's 15,000 US gallons in litres?
15,000 gallons is about 57,000 litres.
About 57,000 litres, 55,000 litres. There's going to be a lot of conversion between US gallons and metric systems here. So we can see that there's a match there. If this was, again, I'll probably say this a few times throughout the video, if this was a domestic pool, which is what this is designed for, there's no problems with any of this so far. The problems come into it when you start comparing these operating parameters with what should be in place for commercial teaching pools. Look at specifications. And here's where I've got a little bit of another problem. Pump flow rates, 2,650 gallons an hour. That's the maximum capacity that that pump will be able to pump water at. The system flow rate, this is what is the concern here. You can only really work out the system flow rate once you've got that pump attached to a system and that system has got a flow rate meter fitted to it. So then you can find out with the pump working exactly what the flow rate is. Maybe they sort of tested it as part of the manufacturing process, and if you set your system up exactly how they set their system up when they tested it and got this flow rate, then okay, it will be the same. But how do you know that your system is going to be set up exactly the same way as they set their system up when they tested it? So it's a theoretical number, but I'm going to use it anyway. And the assumption that I want you to make is that your flow rate is not going to be any faster than that. It's probably going to be slower than that, if anything. And what I'm going to do is work out a few parameters that you need to know. So the first thing I'm going to work out is the flow rate. If the volume, if we go back here, and we said the volume is 55,000 litres, I'm going to put that into cubic meters before we start. So we know that it's 55 cubic meters, and we're going to call that the volume. The flow rate, we need the flow rate so we can work out the turnover time. The turnover time being however long it takes to move 55 cubic meters around the system. We can't work that out unless we've got flow rate. If you've done the pool plant operator course, you should know this, but I'm going to go through it anyway. So we need to know the flow rate. To work out the flow rate, well, we're going to use that figure that we're going to use this system flow rate. But like I said, it's theoretical. You need to know this for sure. So what I'm going to do is convert that into meters cubed. Alexa, what's 2,150 US gallons in cubic meters?
2,150 gallons is about 8.14 cubic meters.
8.1. We're going to round that to 8 just to make it a little bit easier on ourselves. So it's 8 cubic meters per hour, and that's our flow rate. Okay, now we've got those two pieces of information. Now we can work out what the turnover time is. Now, just to give you some context here, what we're looking for is a turnover time that is in line with industry standards, because this is a commercial application here. So we go to the PewTag Code of Practice. There's where you can get it from, free of charge. Go to the Code of Practice. If I do a Control and F, search for turnover, it's already in there. Mentioned 32 times, so it's a key piece of information. Go down to where it tells you how to work it out as well. Here's the turnover times that's recommended for different types of pool. Now, a domestic pool, between 4 to 8 hours, that's a pool that would be in someone's home or in their garden. We're not comparing that. What we're looking for, we're not comparing to that. We're looking for 30 to 90 minutes is the turnover time. So half an hour to an hour and a half for a teacher learning training pools. Why? Why is it higher for that type of pool than a domestic pool? Simply because there's more people There's more people using that pool. There's more pollution going in there. You can't compare a domestic pool usage to a commercial teaching pool usage. There's far less pollution going into a domestic pool than there is going into a teaching pool, and it's for that reason that you need to get that water turned over much quicker. So that's what we're looking for. That's what it needs to be. That's what we need to be operating under. Let's work it out based on the data that we've got. The way that you work it out is quite simple. You take the volume and you divide it by the flow rate. So I'll pull a calculator up on screen so you can see what I'm doing. So let's go 55 cubic meters divided by 8 cubic meters an hour gives us a turnover time of, well, let's round that to 6.9 hours. 6.9 hours. Let's go back to the PewTag code of practice for a second. 6.9 hours would be fine for a domestic pool. But as you can see, for a teaching pool, not good enough. Now these pools are designed for domestic use. That's what they're designed to be used as. They're not designed to be used as teaching pools. There's our first problem. You know, that's not going to be an easy one to get around. That's just the way it is. The turnover time is what it is. And you've got to remember, I'm using that figure, that theoretical figure. It might be in your installation an even longer turnover time than that. The next problem we've got is we know the turnover time is going to be way too slow by many hours. The next problem we got is about filtration. And is the filtration rate appropriate for commercial application? Now, the filtration rate refers to the rate at which water is moving vertically downwards through the filter. And again, there are industry guidelines as to how fast or slow this needs to be. Don't want it too slow, low rate filtration, because you need massive filters and then that affects turnover time as well. You don't want it too fast either, because then pollution it's not giving the filter enough time really to do its job. Plus it can actually push the velocity through the filtration media. It can actually push pollution straight through the filter and it goes back to the pool. What we want is medium rate filtration, and we're going to work that out next. So from my research, I found out that the actual vessel size, the actual filter itself, is 16 inches in diameter. We're going to need that information to work out the filtration rate. Now, working out a filtration rate is a little bit fiddly. I'm going to go through it and you can follow along, but the key bit is to listen to what I say at the end when I interpret that filtration rate. But the way that you work out filtration rate is you take the flow rate. We've already worked that out. We know that that's 8 cubic meters an hour. You take the flow rate and you divide that flow rate by the surface area of the filter. Now there's a formula for doing that. This is where it's going to start to sound a little bit tricky, but working out the surface area of a square is easy. Working out the surface area of what is essentially a circle is a bit more complicated. There's a formula for it, and it's radius squared times by pi equals surface area, and that's what we're going to do now. The vessel itself, item number 37, it's 16 inches. The reason I want to know the diameter is so that I can work out the radius, because the radius is going to be half of the diameter. just a reminder, why do I want the radius? Because I want to do this formula, the radius squared times by pi. If the diameter is 16 inches, the radius is going to be 8 inches. But I want this in metric, so Alexa, what's 8 inches in meters?
8 inches is 0.2032 meters.
Alexa, what's 0.2032 squared?
0.2032 squared is approximately 0.0413.
0.0413. So that's the radius squared. So that's the radius. That's the radius squared. Alexa, what is 0.0413 times pi?
0.0413 times pi is approximately 0.1297.
So that is our surface area. If you're not following along, obviously just go back and replay. Now to work out filtration rate, we need the flow rate divided by the surface area. Alexa, what's 8 divided by 0.1297?
8 divided by 0.1297 is approximately 61.6808.
61. I'm not going to use any of the decimal places. So 61. So this is what we're dealing with. 61. That's our filtration rate. Now let's compare that to the Pewter Code of Practice. So get rid of turnover and put filtration rate. Filters and filtration rate. Here you can see, in general, the greater the filtration velocity, the lower the filtration efficiency. So the higher the filtration rate, the worse. In practice, efficiency falls off even more rapidly at velocities over 25 cubic meters over square meters per hour. This can be demonstrated experimentally using standard water tests for pollution. Filter ratings are based on sand filtration rates. So the 3 categories are ranges only. Low rates up to 10 cubic meters per hour. Medium rate is the recommended one, 10 to 25 per hour. High rate is 25 to 50. So we're off the scale. The loss of pressure through the filter is directly proportional to filtration velocity within the range of 10 to 25. So for conventional public pools where bathing loads are consistently high, same with teaching pools, a medium rate filtration rate of 10 to 25 is recommended. Okay, let's go back again and see what these pools generate is 61. So it's way too high. So we've got multiple problems here. We know that the turnover, based on the calculations I've done on screen for you, using information directly from the manufacturer, the filtration rate, the turnover is way too slow. The filtration rate is way too high. What that means for you, if you're an operator of one of these pools, is you're going to have to make some very careful decisions about how you choose to operate it, and the numbers of people that you have going in the pool. All of these factors need to be included as inputs into a thorough and comprehensive risk assessment of the provision of these pop-up pools for school swimming lessons. These aren't the only factors to consider, by the way. There are lots of other factors to consider as well, such as how are you going to maintain the chlorine level at the correct range, because these systems don't typically, I believe, come with automated dosing systems. How are you going to control the pH to make sure that that chlorine, once you've got it successfully introduced into the pool at the appropriate rate, is actually effective? Chlorine effectiveness drops off massively once the pH goes above a certain level. There's all sorts of other factors as well that go into it, but what I wanted to do is just put together this quick, well, not so quick video now, but put together this information for you, because I realise that some of this information is quite tricky to work out, so that you can make quicker decisions. You can quickly come to a conclusion about whether your pool is actually even operating under standard industry guidance, and then you can use that information as a key input into your risk assessment process. Hope that's been helpful. Any questions, leave them in the comments and I'll do my best to get back to you.